Hello, ladies and gentlemen. We're going to look at lesson 15, which will give us more practice on inequalities. If you happen to have the book, it's page 90. If you don't, no big deal. You can just follow along with what's on the screen. Two identical cars need to fit into a small garage. The opening is 23 feet 6 inches wide, and there must be at least 3 feet 6 inches of clearance between the cars and between the edges of the garage. How wide can the cars be? So let us first draw a picture of this. So we have a double car garage, and then we've got two cars inside here. I'll make Beatles or something around here. That's kind of silly. The space between them must be at least 3 feet 6 inches of clearance. So 3.5, because 6 inches is half of a foot. But that is between the cars and between the wall and the cars. And then the whole thing all the way across is 23 feet 6 inches, which again is a 0.5. Okay, do we have one of those magical phrases that we learned about yesterday? At least 3 feet 6 inches of clearance between the cars. Now, I want you to be careful on this because how wide are the cars? So we know that this is 3.5 in these spots. So we would like to know how wide the cars are. So I'm going to write, we know they're both identical cars, so we could put X's in both of those. I'm going to put 3.5 plus an X plus 3.5 plus an X plus 3.5. Okay, so I just went across here, right down the garage. And that's got to make 23.5. Now I know it says at least, but they're talking about the space between the cars, and I want to know about the cars. So I'm trying to find X being the cars. So I cannot go above 23.5. That is how big how big the garage is. So it needs to be less than or equal to 23.5. Okay, I'm going to combine my like terms, 2 X's, and the 3.5s makes 10.5. And now we're going to solve. Divide by our coefficient of 2. None of these were red flags. So those cars can be 6.5 feet or smaller than those. This problem, I really don't like that they put this at least up here with the 3 feet 6 inches, because that is not something we're trying to figure out. We are saying that there's 3.5 feet in each of those spots. So that was kind of a poorly designed question to have that in there. A local car dealership is trying to sell all of the cars that are on the lot. Currently, there are 525 cars on the lot, and the general manager estimates that they will consistently sell 50 cars per week. Estimate how many weeks it will take for the number of cars on the lot to be less than 75. Write an inequality that can be used to find the number of full weeks, W, it will take for the number of cars to be less than 75. Since W is the number of full or complete weeks, W equals 1 means at the end of week 1. Okay, so we don't need a let statement. They already told us let the W be the weeks. And you see that magic phrase somewhere in here. We want less than 75. So a straight up, just less than symbol, no or equal to, just less than 75. There are currently 525, so that is what we're starting with. And they are trying to sell. So in the idea of cleaning out the lot, selling would mean subtracting. So we are subtracting 50 per week. Okay, now we're going to solve that. I really need a little bit more space. Guess I can fit it in here. Minus 525 on both sides. 525 minus 525 is gone, leaving negative 50W. The subtraction sign became a negative. It can't disappear. Then I got 75 minus 525 is negative 450. I'm going to divide by negative 50. And that is a red flag. So I'm waving that red flag right now, and I'm going to flip that inequality around to a greater than sign. For negative divided by negative is positive. 450 divided by 50 is 9. So the weeks should be more than 9. Interpret the solution in the context of the problem. So that means using the words from the story. So they will have less than 75 cars after 9 weeks. 10 weeks they'll have even less, 11 weeks they'll have even less. Verify the solution. They want you to give it a try. So what that would mean is we would plug it in, 525 minus 50, and then we'll pick something bigger than 9. Let's pick like 10's an easy one. So that would be 525 minus 500, which would be 25. 25 is less than 75. So after 10 weeks, they will have less than 75 cars on the lot. The cost of renting a car is $25 per day, plus a one-time fee of $75.50 for insurance. How many days can the car be rented if the total cost is to be no more than $525? Write an inequality to model the solution. So do we have one of those magic phrases? No more than. So if it's not more than, it is going to be less than or equal to that 525. The cost of renting a car is 25 per day, so let's let D be days. And then it will be 25 per day. And $75.50 for insurance, a one-time fee that happened once. Okay, so now we're going to solve that. So I'm going to minus the $75.50. $449.50 divided by 25. There were no red flags, so we are still doing a less than or equal to 17.98. Okay, so I want to see that now, like that answer doesn't make a lot of sense here, but I want to see exactly what the math gave you. So we're saying that D is less than or equal to 17.98, and now we're going to interpret that solution in the context of the problem. So D was days. So the cost of renting a car, how many days can the car be rented if the total cost is to be no more than? So I might say for the total to be no more than 525. Is this, should I say you? I guess I should say you. You can rent the car for, so something less than 17.98 for 17 days or less.